Okay, hello guys and good evening. My name is Haziq bin Shamsuddin. I'm going to explain about the unification process in petroleum conversion. So in this topic, first I will first introduction and next alkylation, the polymerization, and lastly I will conclude the topic. So basically, what you know about the unification? That is a process of combining smaller pieces of hydrocarbon to make a larger one. Uh, there is two type unification process, which is alkylation and polymerization. Uh, there is a refining flow diagram. The alkylation is located in here, as you can see in the screen. The feedstock for alkylation is for isoparaffin is come from hydrocracker, where the olefin, which is butane and pentane, come from fluid catalytic cracker (FCC). The product of alkylation is alkylate, or we call isooctane. This is overview of the conversion process unification. First, you can see the process, the action involved in this process, and the method used, the purpose of the two process, the feedstock used, and the product of the process. So let's start with alkylation. First, alkylation is the combination of low molecular weight olefin with isobutane in the presence of highly acidic catalyst to produce a mixture of higher molecular weight isoparaffin. It is commonly involved the reaction of isobutane with isobutane or N-butane and produce isooctane. In case you know, N is a normal, is a short term. So the isoparaffin have octane numbers vary with the olefin from which they were made. That means that the product of alkylation is depend on the olefin we use. As many olefins such as isobutane, butane, so this depend which is good. So in the alkylation process, the catalyst we use is sulfuric acid, hydrofluoric acid, and aluminum chloride. So aluminum chloride we not usually use. We use only these two. The reaction temperature for the sulfuric acids is in the range of 10 degrees Celsius to 16 degrees Celsius, and for the hydrofluoric acids is around 27 degrees Celsius to 0 degrees Celsius. So in the alkylation process, when we involve the acid catalyst, is an exothermic reaction. That's why we require a refrigeration to control and maintain the temperature to increase the performance of the process. This is alkylation reaction. So first is the reaction between the olefins and the isoparaffin will result in isooctane. Same like below, it is olefin and is also isoparaffin. So this different olefin will result in different product that based on the quality. So the quality also different. So we go to feedstock, which is the feedstock for the alkylation is propane and olefin. The olefin is come from the catalytic cracker. The olefin, which is butylene, produce highest octane numbers, while pentylene intermediate and the propylene the lowest. So the butylene is the preferred olefin. For the paraffin, we usually use isobutane because this paraffin is recovered by refinery gas and produced by catalytic butane isomerization. And the less preferred one for the paraffin is isopentane because it's a good gasoline blend stock. So this is not good for the catalytic alkylation unit, but it's good for the another process, refining process. So we go to product. The product of alkylation is alkylate, which is called isooctane, and also high octane gasoline. The product is desirable component for higher performance automotive fuels such as cars, a train, and motorcycle. And it is high octane hydrocarbon more than 87, which is used in gasoline blend to reduce knocking. The product is also low vapor pressure and it has no olefin, benzene, or aromatic. So we go to the alkylation process variable. So there is 4 variable, which is reaction temperature, acid strength, isobutane concentration, and type of olefin. So let's look at the reaction temperature. If the temperature is too low, it will increase acid viscosity, hinder the good mixing of reactant, while if too high, the side reaction will set in. The second one is acid strength. The presence of water will lower acid activity. Acid is considered spent at around 80% of sulfuric acid. For the third variable, the higher the ratio, the better the octane number, which means the olefin ratio, the olefin must be surrounded by isobutane. So in the reaction, the isobutane must be in excess to make to increase the performance of process. Lastly is type of olefin. So the most good one is butylene, because it produces highest octane isooctane level. The second good is pentene. The side reaction is frequently occur, so is this intermediate, and the worst one is the propylene. Because the octane numbers are low, that's why we commonly use the butylene as a olefin. So let's go to the alkylation process. So there is two types. First, sulfuric acid, and the second one is hydrofluoric acid. This is schematic of sulfuric alkylation unit. First, you have know that in alkylation unit, they must have chiller, reactor to mix the feedstock, and the third one is the acid separator. The fourth one is caustic wash, and lastly is distilling column, which is such as the propanizer, the isobutanizer, and lastly is the butanizer. So a low temperature in sulfuric acid process, a low temperature process employing concentrated sulfuric acid catalyst. So the chiller is needed to bring the temperature of feedstock down to 7 degrees Celsius. The chiller is like a refrigerator. The feedstock stream is sent to reaction zone, which this zone is also we call reactor, and mixed with the stream of H2SO4. So the reaction we require enough pressure to keep the mixture in liquid form. The reactor they also has a mixer to ensure the good contact of olefin, which isobutane, and the catalyst also. The next mixture of acid and hydrocarbon will separate in the acid separator. The hydrocarbon vapors are withdrawn from the top of the reactor, while the acid at bottom are recycled back to the feed at the first reactor. After that, they go to the caustic wash, where we use the caustic soda, such as potassium hydroxide, to remove the trace of acid in hydrocarbon. After that, they go to the fractionator to separate the alkylate and saturated gas. The saturated gas, which is the unreacted isobutane, is recycled to the first reactor. Next, we go to the hydrofluoric acid process. This is the diagram of its unit. So, in HF process, there is two processes, which is Philip and UOP. So, let's take a look at the Philip first. The feedstocks dry and fixed to combination of reactor and settle unit. So, in the Philip, the settle unit and the reactor was combined. The hydrocarbon from settling zone is charged to main fractionator. The main fractionator overhead goes to a depropanizer. Overhead is like a top of the reactor. The propane, which the trace amount of HF stripper, then catalytically defluorinated. Defluorinated also we can call as a depropanizer, and it was treated and sent to storage. The isobutane is withdrawn from the main fractionator and recycled to the settler. So this is the unreacted isobutane. Alkylate from the bottom of the main fractionator is sent to splitter for the further process. In the UOP process, it's different from the Philip process because the settler was separate from two reactor. Half of the dry feedstock is charged to the first reactor along with recycle and make up isobutane. Then to each settler, where the acid is recycled and the hydrocarbon charged to the second reactor. The other half of the feedstock goes to the second reactor, with the settler acid being recycled and the hydrocarbon charged to the main fractionator. The overhead from the main fractionator goes to the depropanizer. Isobutane is recycled and alkylate is sent to the splitter. Fractionator, if you don't know, is the butanizer and the isobutanizer. So this is a schematic diagram of hydrofluoric process. Hope you can understand the whole process in the diagram. So let's move on to the polymerization process. I think you can understand this diagram. The process is almost similar to the alkylation process. It has a stabilizer, which we call distillation column. Also has a caustic watch and acid splitter, and the unit is all the same. The difference is only the process. The process in polymerization involves the combination of olefin such as propane and butylene to produce higher olefin with higher octane numbers for the gasoline pool. So the polymerization combines two or more identical olefin molecules to form a single molecule which is the same element in the same proportion as original molecule. The polymerization may be accomplished thermally in the presence of catalyst at lower temperature. The feed for the polymerization is hydro-treated olefin stream. The feed must be hydro-treated first to reduce the sulfur content and also another undesirable component or impurities. The catalyst used is a solid or liquid phosphoric acid, sulfuric acid. Since we use the acid catalyst, we require the use of cooling water and the injection of cool feedstock because because we know the acid will cause the corrosion of the equipment in the refinery. That's why we use cooling water and cool feedstock. So the product for polymerization is high octane naphtha, petrochemical feedstock, and liquefied petroleum gas. So here the summary of the whole process in polymerization, starting from the feedstock and where it come from, and the process, the product, and where the product will go after that. So this is the end. Before I end my topic, I want to ask two questions before I end this slide. First question is, give me the variable include in the alkylation process. So the next question is, uh, give me the difference between the polymerization and alkylation process. So I want you to answer this question under the comment section in the YouTube. Okay, that's all from my part. Thank you for your attention.